Leah here from LeahForSci.com, and in this video we'll continue the Diels Alder reaction by looking at Cyclo reactants and Bicyclo products. The tricks referred to in this video were taught in part 1, so if you haven't seen that, go back to my website LeahForSci.com/Diels Alder, where you'll find the entire video series along with the Diels Alder reaction guide and practice problem set. In part 1, I showed you how to set up this little key as a trick for the Diels Alder reaction, and we also used a molecule that was oriented differently and made it fit that trick. But what if I tell you that you're starting with two molecules of 1,3-cyclopentadiene and reacting it with heat to form a Diels Alder product? How do we make the ring fit that little trick, that little key here? Well, organic chemistry is not an art class. It may feel that way, but as long as you draw your molecule correctly, it doesn't have to be pretty. So to start my reaction, I always want to start with a pattern of 1, 2, 3, 4 for the diene. And remember, it's not an art class. So if I close the ring over here and put that as position 5, that's fine, right? But what if my drawing is a little off and I exaggerate it and put it over there? Is that still correct? Yes, it's not drawn very pretty, but it's correct. What if I now take carbon 5 and put it all the way up here? It doesn't look right, but as long as carbon 5 is attached to carbon 1 and to carbon 4, it's technically correct. Now recognize the bonds can bend that way because carbons 1 and 4 are sp2 hybridized, meaning they're trigonal planar and flat. But for the sake of this reaction, I'm just drawing it out of the way. I'm exaggerating it so that I can make my diene look like the standard form. For the dienophile, I can rotate the molecule so that I use either of the two pi bonds. It doesn't matter because we have a symmetrical starting molecule. So when I set it up, I make one of the pi bonds face the diene and label that A and B. Add some heat to get the reaction going, and that's it. Now remember, I showed you that you cover your starting molecules. You don't want to get confused by all those bonds. Instead, you want to go for your known product of a cyclohexene with a pi bond between carbons 2 and 3. Before we look back at the reactants, we want to number it following the pattern 1, 2, 3, 4, A, and B. Now that we have the skeleton for the product, let's go back and see what else we want to add. Carbons 1 and 4 are attached to that funky looking carbon 5, so we'll put carbon 5 up there and attach it to 1 and 4. For A and B, we have the ring continuing, so let's call that C, D, and E, where E fuses back to A. So if we have B, let's go with C, D, and E, which fuses back to A. And last but not least, we have a pi bond between C and D, so we'll put that in. And that's our product. It's not very pretty. It would have been hard to get if you tried it directly with the mechanism. But by breaking down the core reaction to look like our Diels Alder template and then filling in the missing pieces, the product just pops into place. When you have a Bicyclo product, it can be represented in different ways, so make sure that no matter how you see it, you recognize it. And how do you recognize it? Because of the numbers. So let's simplify that bridged molecule. If you have a molecule that looks like this, where we have that number 5 on top, number it as follows: 1, 2, 3, 4, A, and B, and that's number 5. You may also see the breadbasket version of this molecule, where instead of having the hexagon, both sides are kind of pointed down. We still have the pi bond here, and that's our funky 5 up there. Let's prove it. 1, 2, 3, 4, 5, A, and B. You may even see this thing upside down so that it looks like this, but we still have 5 on top and still have that pi bond. Once again, 1, 2, 3, 4, 5, A, and B. They all represent the same molecule, they're just drawn slightly differently. Now let's see how to undo a bicyclo compound. So here we're given a bicyclic product, and we're asked to find the starting molecules that underwent a Diels Alder reaction to form this product. We'll have our trick template to refer to, and first thing, identify the pattern. I see the pi bond, and that means that's carbons 2 and 3 in my cyclohexene product, and we'll label it 2 and 3, which means here we have 1 and 2, A and B. Let's number and label everything else so we can figure out where to go with it. Attached to carbons 1 and 4, we have carbon 5. Attached to carbons A and B, we have a carboxylic acid. So for B, we'll call that one C, and then we'll call the lower one D. I can use the pattern of breaking between 4 and A, 5 and 1, or go back to the other trick of break, make, break, make, break, make. Starting with a pi bond between carbons 2 and 3, we are going to break a bond, make a bond, break a bond, make a bond, break a bond, and make a bond. Then we draw it exactly as we see it. So we have 1, 2, 3, and 4, with a new pi bond between 1 and 2, another one between 3 and 4, and carbon 5 attached somewhere up top. For the other side, we have a pi bond between A and B, and then attached to A and B a carboxylic acid. I want you to recognize that the carboxylic acid is in the up position on carbon B, in the down position on carbon A. If they are facing opposite directions and they're attached to a pi bond, that means the starting molecule had to be a trans pi bond. If they were both facing up or both facing down, then it would be a cis starting molecule. It doesn't matter which one you put on top and which one you put on the bottom, meaning do I put this one, do I make it trans like this or trans like that? Because this molecule does have symmetry, so as long as it's trans, you're good to go. So we have a carboxylic acid trans to the other carboxylic acid, and these are our starting molecules. Now what happens if your starting molecules are asymmetrical? How do you know how to orient the starting molecules when fitting it into your pattern, and how do you know what to put up and what to put down in your product? That's exactly what we'll cover in the next video, which you can find along with the Diels Alder reaction guide and practice problem set by visiting my website layitforsci.com/Diels Alder. Are you struggling with organic chemistry? Are you looking for resources and information to guide you through the course and help you succeed? If so, then I have a deal for you. A free copy of my ebook, 10 Secrets to Acing Organic Chemistry. Use the link below or visit orgosecrets.com to grab your free copy. After downloading your free copy of my ebook, you'll begin receiving my exclusive email updates with cheat sheets, reaction guides, study tips, and so much more. You'll also be the first to know when I have a new video or live review coming up. If you enjoyed this video, please click the thumbs up and share it with your organic chemistry friends and classmates. I will be uploading many videos over the course of the semester, so if you haven't subscribed to my channel yet, do so right now to be sure that you don't miss out.